Oh, it has a countdown timer. I like that. All right, let's look at this. We have our lesson here from the book. And in the chat, go ahead and let me know, what question should I look over? What do you think? Who has the first questions? We did number 1 together. I think you guys are working on 2 and 3. But let's see, what was the assignment for this? We had to do 1 through 8, or let me double check. Number 4. Okay, so I see number 4. 4. What else? Let me just check that real quick because I want to make sure we're doing the right one. Here we go. All right, so the assignment was 1 through 8 in workbook, 1 through 8 in the book. Okay, so I'm assuming these are in the workbook first. And I have number 4 coming up. Number 4, very good. Let's just do that and keep them coming if you have others to work on if you want. All right, number 4 here in the workbook. Now remember, you might have that one other page open, page 29 in your workbook. Remember, page 29 had our steps. So go ahead and have that also accessible, page 29. And let me pull that up for us to look at, because remember, this has our steps, and especially if you're getting lost, I want you to really try to follow these steps. Okay, so let's look at number 4. Read the problem statement carefully. Okay, let's just read it. Okay, it costs Rachel $5 to in tolls to drive to work and back each day. Plus, she uses 3 gallons of gas. It costs her a total of $15.50 to drive to work and back each day. How much per gallon is Rachel paying for her gas? How did you know? Okay, so we did that. Now we're going to read through it again. Number 2 is read through and go ahead and put a list of all known quantities, and let's just write that out. Remember, this is the part where you don't have to throw it into the expression yet. You can just go in and just start taking out some information. Okay, it costs Rachel $5 in tolls. Okay, so toll road is where you got to pay to use your toll. Okay. Pay to use that road. And let's see, to go to work and back. So this is, to work and back home. All right. Plus, she uses 3 gallons of gas. Okay. It cost her a total we're talking here, of $15.50. All right, to drive to work and back each day. So that looks like it includes everything, okay? 3 gallons of gas. So how much per gallon is Rachel paying for her gas? How do you know? Okay, so we have a contained trip. We're going from home, we're going to work, and we're going back. We know that that is always going to cost $5, right? Because the toll for there and back is 5. So now I want to just try to figure out step 3 is to read the statement, identify the unknown quantities. So this is from page 29 in the workbook that has our steps for creating these equations. Okay. All right, Jessica already has something in the chat. Perfect. That looks good. That looks good. Okay, I want to write it out slightly different here. Okay, so our total is $15.50 though. What we don't know, 3 gallons of gas. So 3 gallons of gas, but what I don't know is the cost of the gas, right? Because this could actually change. Gas prices go up and down a lot, and it's kind of weird how it's organized around the world. Okay, but if I look at this, we know it's going to cost $5 for tolls, plus the gallons of gas, 3 gallons of gas, and I don't know the amount, and that's going to equal 15.50. So $15.50. So Jessica, look at that one more time. Try to see how we're going to go about this in a slightly different way. Okay. Now, looking at that, we have the toll. We have the gas, and we have the total. So this is ready to solve. We have our equation already set up here. It's important to think about each component and see if there's an aspect where you have like a variable to it, like the price could change, right? Because look, if you guys remember, well, I don't know if you remember this kind of stuff, but when was it? No, it'd be too long for you. But 5-6 years ago, I think it was 5 or 6 years ago, the gas prices were really high. Okay, So the gas prices can get up to like $5 a gallon. 15 years ago, it might have been down at, $2 a gallon. So this is going to make a big difference. And this is why actually people really like when prices go down. That's why, you ever go to Arco, you see how crazy like the cars are like in lines at Arco to like save money. Well, the thing about that is you got to like decide, do you want to even stay in that line? If the cost per gallon is 10 cents less, you're going to save $1 because you're going to put 10 gallons into your tank. So I think people kind of see a low price and they don't do the math in their head to see, well, how much are you actually going to save? Because I never go to Arco. Because the gas quality, and it's always so busy and there's always turmoil in that gas station. So if you go there, that's fine. But just know that like it's a drop in the bucket. It's only like 10 cents cheaper. It's maybe not even worth it. You can save $1, but people spend money on, coffee and other things that are more than $1. Just keep that in mind. Oh, I see, Abby. Okay. Let's do that. All right, good. So we're going to just solve this. And remember, I was teaching before, and I think it's a good review here. X is connected by a chain to 3, and X is connected to it with a chain to 5. And we could see here that this chain is multiplication. This chain is addition, okay? So we need to break our chains, and we're going to go from the outside in. Just like peeling an onion, you always solve from the outside in. So let's get rid of this 5. It's a positive 5, so let's subtract it. Okay? And when we go about doing that, it's going to negate out. When you combine something that makes it equal to 0, it negates out. So the positive 5, our total cost has been negated, and now we just have to rewrite this guy. 3x is equal to $10.50. Okay? Now, if you want to really play this chain idea up, you look again, you say, oh, it's connected with multiplication. You always do the opposite operation to both sides. So instead of multiplication, we could break that chain by dividing by 3. Okay? So these are the fundamentals. That's kind of why I want to slow down a little bit. So solving equations is something we'll get a lot out of these exercises. And we're going to cancel the 3 because 3 over 3 is 1, right? Okay. And then I look here, and what do we have? We have x is equal to, I'm going to go off what people are saying in the chat because I'm going to trust that. $3.50 per, right? Per gallon. Remember that the units are very important with this. Okay, the units are really important. And sometimes the units are going to help us solve this. So remember, all these answers at the end here, I need you to put, so Abby, right on, you got it. I need you to put the units there as well. Otherwise, it's just 350 and you might get confused. Okay. All right. Give me a thumbs up, sideways, down for like just seeing how we go through that. You feel pretty good about it? All right. Give me a thumbs up, sideways, down for solving the equation. And I don't care if it's sideways. If I want to see it if it's not quite strong yet. Okay. All right. I see a slightly confused face. So is anybody, maybe in the chat, if you could tell me kind of if you're a little confused, I can try to teach it a little different in the next one, okay? All right. Okay, good. Thanks for starting to write that up. Okay, so this was number 4 in the workbook. I had another request come up for number 2 in the workbook. So we're going to go ahead and bring that down, okay? Good to speak up when you need help because that's how you get help. And you want to get used to doing that. I'll tell you one mistake I made in college. I did not access my peers as much as I could have. Like I didn't have them peer review, like read through my essays and all these other things, okay? And that was like a mistake. That was because I had like too much pride. I didn't want somebody to tell me that it wasn't right or whatever. And my work was good, high quality, but I could have been better if I asked for support. It's not weakness, it's actually strength, okay? So when you get into business, if you go into business or you're working in professional environment, the people that know how to ask for help and have tact with that, it's going to help you out a lot, okay? So it's not weakness to ask for help. All right, let's look at number 2. I'll start with black ink. All right, let's look at what are we going to do first? On page 29, it tells us our steps. We're going to read the problem statement carefully. So let's look at the problem statement and read it carefully. Okay, so you need to buy new tile for your kitchen. The kitchen measures 13 and a quarter feet by 7.5 feet. What is the area of the kitchen that you calculated? What is the most accurate area you can report to your hardware store to order and purchase your tile? All right, guys, these are all things that you'll probably end up doing. Okay, so keep that in mind. If your internet's bad, no worries. You could, Natalie, try to turn off your video. Sometimes that allows more streaming bandwidth for other things. And random question here about what colleges I went to. I've gone to UC Berkeley, UCLA, and University of Laverne. Those are my big schools. So, I've competed and had peers that were top of the game. So I know what it takes to get in and do well there. Hopefully, you know what? Honestly, the students that do the best are the ones that could deal with the stress of school. I mean, everyone has innate talent and whatnot, but if everyone's working hard and can deal with stress, that's the main thing that people sometimes are missing. Okay, so you don't want to run yourself into the ground where you don't have anything left every single day. You got to figure out ways to work through the stress, guys. All right, so here we go. Let's look at this. We're going to go ahead and draw something here. So I have a kitchen that is 7.5 feet by 13.25 feet. Okay, what is the area of the kitchen that you calculated? Okay, let's see. What do we know about area of a rectangular shape? It's going to be length times width, and that's going to be equal to our area. Okay, so with this, I think that we have a pretty straightforward problem. Let's see what else they're asking. What is the area of the kitchen that you calculated? Great. What is the most accurate area you can report to your hardware store in order to purchase enough tile? And I'm looking at this and thinking this is way too straightforward. So let me see what they have in mind for this, because I just can't imagine that this is all they want us to do. Really? That's all you need? Okay. All right, so we have our equation for this. Yeah, we can do 6. And I look here, and length and width, it won't matter because we multiply two things together. Transitive property, doesn't matter which comes before each other, which one comes first. So let's go 7.5 times 13.25. And that is equal to our area. Now, with that, there's no other variables. There's not really any unknown other than the area. So this is a very straightforward problem that we can do right here and then have our square feet. Let's see. Yeah. And the reason too that, let me write this here. This is 7.5 feet. Go ahead and write it here as well. 13.25 feet. So when we multiply these together, we're going to end up with, who got it? Can you throw it in the chat? I can get my cheap calculator and do it too. All right. 7.5 times 13.25. All right. And we get 99.38. And then I want you to tell me in the chat, what are the units going to be? And my hint is that within the problem, I did put the units here. And what happens when you multiply those two units together? What is feet times feet? Very good. Maybe you know this because area has that typical, that typical same measurement, units. Good, Abby, you got it. Mia, perfect. Sophia, good job. Good. So I'm seeing here that we have feet squared, or square feet. Okay. Square feet, remember the area is all this, and that's what you have to know if you're going to put down tile, right? So, I'm doing some home improvements on my house. I had to find the surface area of my entire house. So I had to measure and make composite shapes, because one side of my house is like a really weird dynamic to it. It's like it's kind of like this. Well, that's like the side view. So what I did was, I broke it into shapes that I'd be able to measure, length times width. So I found this, square footage. Then I did this, height times base times a half. I found that square footage. And then, this one I had probably to break down like that. I find all these square footages, and then the composite is all of them added together. So composite shapes are what we do in order to figure out, yeah, I know. Thanks. Composite shapes are what we use in order to find kind of strange shapes that aren't standard, you know, trapezoid, square, rectangle, triangle. Okay. All right. So this was actually the answer for this. Honestly, I feel like this is kind of like a curveball. Number 2 is a curveball because it doesn't have the same level of, you know, trickiness here as the other problems we did. But maybe it's just a warm up. It was number 2. So this was number 2 in our workbook. And maybe this was something you had to write down. Okay. So let's do that. This is for any kind of rectangular square. Its area is going to be length times width. For a triangle, it would be 1/2 the base times the height, right? And I think for now, for solid geometry, or actually for 2-dimensional geometry area, you're just going to have this. Now, here's something to know. For instance, when you go to do the SAT, it's not like you have to know everything, right? You are going to be given a formula list, and it's going to be helpful. Anytime you're up against a test, it's helpful to learn everything about it. Like kind of be like a spy, right? Like figure out, you know, what are the most common standards that are covered, and then study those standards, right? That's all they would teach you if you went to a Kaplan, you know, Kuhlman kind of a training session. They just have done the research to figure out what kind of problems there are. And they'll say, hey, don't memorize these. Don't memorize these because all of these equations formulas are given to you, right? Did you know you didn't have to memorize that, right? So maybe you didn't know that, but you have to learn what you're up against and always kind of approach it as if it's like something to overcome, right? I like to think of it as like my research when I'm figuring out what they need in the test. It's almost like I'm a spy. I'm just figuring out how to get a little bit of an advantage, okay? All right. So that was number 2. I saw a request for, what was it? Who said something? Anybody? 6. Okay. And let's look at number 6. This was number 2 in the workbook. And let's flip the page. Okay. Yep, this one's more of what we were doing in the class. So again, I'll keep on referring you. You got to look at that page 29. That tells us all the steps we need, all 6 steps for any kind of equation or inequality, okay? So the next lesson I think is going to be really similar. We're just going to do more with inequalities. So we're going to stay in this. So if you're like, I need more work on this, you'll get more work, don't worry. Who's thinking that? I need more. All right, 100. Okay, Jessica, not sure what that means. Help me out. Write something else in there. I'm not sure what you mean by that. Okay, let's read it first. Just read it, okay? It costs Justin $100 to have cable TV installed in his house. Each month he pays an access fee plus a tax of 7% of his monthly bill, okay? After 6 months, Justin had paid a total of $350.38 for his access fees, taxes, and initial installation. What is Justin's monthly access fee, not including taxes? Okay, there's a lot to it. No worries, right? So read it first without any burden to understand everything as you go, okay? Read everything first. Oh, I see. Ooh, nice. Okay. All right, Jessica, I understand now. Good job. Let's look at this then. Let's write down what we have known, and then we'll figure out what we don't know. Okay, so it cost Justin $100 to have the cable installed. Okay, so let's say install $100. Okay. Each month he pays an access fee plus 7% of his monthly bill. Okay, so each month, let's say the monthly access is some amount. I don't know. It doesn't say. But then they say as well each month, right? Each month there's also a 7% tax on that access cost. And you might see that, you know, if it says that your phone bill will be $100 a month, it's not going to be $100 a month, right? It's going to be $100 plus taxes, plus service charge, and all that, right? They try to trick you. They're like, it's 99 cents. Nothing's ever what it is. It's going to always be a little bit more. All right, so we have the 7% on his monthly bill. And then it's saying after 6 months, you've paid $350 $3.38 for his access fee, taxes, and installation. So this includes everything. Okay. So the way that you write it out and like how you kind of make your own notes, that's up to you. I just like to make little almost diagrams to see, what each part is here. So our question is, what is Justin's monthly access fee, not including taxes? And I already put that as my unknown. So essentially, while I was rereading and finding the known quantities, I also was trying to see, well, what's the unknown quantities? And now we're doing number 4, create that equation. Okay. So here's the thing. All of this, right? All of this from our notes after 6 months equals our 350.38. So I'm going to put 350.38 over here on this side of the equation. Because I know that all of this stuff that I kind of circled here, all of that after 6 months is going to add up to here, add up to this. Now, we know that the tax is only applied to our monthly access cost. Okay, so like these two things are going to be connected. It doesn't say anything that the tax was applied to our installation fee. So here I can set it up as the installation fee is just, that one-time fee that comes in. It doesn't have a tax to it, apparently. Yeah. The installation fee, we're going to add to it because all these costs added up to 350. So it's apparent here we need to add. And what we're going to do is, let's see, we need to add our X, which is the monthly cost. So this is access, monthly access. And not just 1 month, because how many months did we do this for? We did this for what? 6 months, right? Yeah, 6 months. So the thing is, first, I'm just going to put parentheses right here. I'm going to leave a little room because I want to be able to look at the monthly tax and the monthly access right here, okay? I want to look at it all right here. And then what I'm going to end up doing is, since it was over 6 months, I could put a 6 out here, and that tells me that we're looking at each month of service and tax, and we're just going to multiply it by 6, okay? And I see different ways people have set this up. Jessica, you got it perfect. That's great. And that is actually the direction we're going, so great job. All right, so here we go. We had the installation cost. We're setting it up here to find what the monthly access and tax is, and then we're going to multiply it by 6. That is going to give us all of the access and tax over 6 months, plus the 100 is going to give us our total after 6 months. So if I look at this, this is where it gets tricky, and I feel like if you guys agree, just like give me a thumbs up. Is this where it gets tricky? Is that where it gets tricky? Thumbs up if you agree. Okay. Now, this is actually something that sometimes math is just to like not have anybody take advantage of you, honestly. Because if somebody guarantees you a price, especially if you go buy a used car or whatever, like they know that the average public gets confused on this kind of stuff, right? And honestly, that's where they'll shave off some points. So I want you to not be tricked by anybody. And that's why I want to spend a little more time on this as well. Because if you think about it, the monthly tax is related to this 7%, but it's not just going to be, it's not just going to be, plus, it's not going to be plus 0.17, right? It's not just plus 17 cents. I mean, that would be awesome, because then you could buy a $1,000 item and you would say, well, it's just plus 0.17. I just got to add 17 cents to that. No, it's not. It's 17% of. Of is that key word. And I think that kind of sentence, if I said, what's 50% of 100? 50% of 100 is 50, right? So it's that same idea, 17% of our monthly access fee. That's how much our tax is going to be on each month's service fee. Okay? And I'll keep reiterating that, but this is really the key. And this is where, there's little places where there's fraud that could happen. And sometimes in the service charges and all that, you may be overcharged based on tax or whatnot. So you got to be really careful, okay? So here's what I'm going to put here. I know that I'm looking for the monthly access fee, and I'm looking for 17% of that monthly access fee. 17% of the monthly access fee. So when I combine those together, I get 0.17x plus x. Okay. We'll keep seeing this stuff. So don't worry if, we got another problem probably that's really similar. It's 7%. Oh, you get cadence. You get bag of Starbursts. Wow. Okay, so guess what? You know what's good for this? You know what's good for this? One of my favorite things from Staples. Never happened. Ooh. It happened. We don't hide our mistakes. We just fix them and not flinch. All right. So we have 0.7. And that is going to be 7%. That happens sometimes. Okay, so let's go ahead and kind of clean this up a little bit. We're right here. And now I just need to combine the terms I can. I want to think in my head here about PEMDAS. I want to think PEMDAS. I want to think about like terms. So let's look here. Inside the parentheses, yes, we can simplify this. Inside the parentheses, we could simplify this. So I'm just going to rewrite everything else plus 6 times. And this is 1x, right? That's 1x. So what's 1? Think about it. $1 plus 7 cents is $1.07. And I just use that to try to relate something that you're more used to working with. So we have 100 plus 6 times the quantity. And this was our service charge and tax combined. I didn't know how much my monthly service is, so that's why there's an X in there still. And then let's go ahead and do this. And here there's a couple things that you can do. You can do a couple different things. Let's just follow PEMDAS. So one thing that you could do would be to subtract the non-PEMDAS, kind of like a clever way you could do is minus 100, divide by 6, and then you'd have this to deal with at the end. Okay. But let's use PEMDAS because here we're going to do multiplication before we do addition. So let's multiply these in, and we're going to get 100 plus 6.42x is equal to 350.38. Yep. All right. All right. So now we have to look in, we have to just solve this out. And I'm going to use PEMDAS again. We got rid of that multiplication. Now we have addition of a positive number. So instead of adding on both sides of the equation, I'm going to subtract. Oops. You can even put a line there if you like to keep things super neat. And what we end up with is 6.42x is equal to 250.38. Okay? 250.38. All right. So looking at that, we have one last step. The chain to x is multiplication, so I need to break it by doing division. It's always the opposite operation to both sides, and then you know that you haven't really changed anything if you change it in the same exact way. It still balances, okay? This negates out because this is essentially 1. It's equal to 1. The same thing over itself is equal to 1, so we can cross it out and say, well, it's really 1x is equal to, I'm going to go with, Jessica says 39. 39 what? 39 what, Jessica? Good. It's $39. We'll say per month service charge. And however you elaborate that last part, I mean, as the grader of quizzes and homework and all this, it is dollars. Good. If you explain it in a way that I can understand it, if you said it was $39 for your monthly service, that's fine. $39 for your cable service, each month, I would understand this. Okay. $39 per month service charge, and we could even be more specific. You can write a paragraph if you want, without tax or before tax. And really, I'm going to look and try to match how I explain it, right? I'm going to try to match it with what number was this? 6? This was 6. I'm going to try to match it with what it's asking. What is Justin's monthly access fee not including taxes? So you could say $39 per month service charge before taxes, and that's fine. Okay. So there's a lot of leeway. There's no perfect thing to put here. I know some teachers might say that there's an exact way, but we don't have that. We don't have to do it exactly one way or another. Okay. You want to think of it as a little more organic like that. For instance, if I said for you to write, a thesis statement about how your summer was, there's no perfect way to do that, right? There's no perfect way to do that. So I want you guys to know you have some creative control a little bit, okay? And don't worry about it. As long as you feel like I'll be able to understand what this value means, we're good to go, okay? Okay, let's see what you have as far as any other problems we need to look over. And if we don't get through all of these, I'm going to be recording these homework reviews in all my Math 1 classes. So by tomorrow, I think we'll have all of these problems worked out by tomorrow night. And I'll probably post them tomorrow night, and that'll help you guys prepare for Monday to have them all done. All right. What do we got? Any others? Hey, it's fine if there's no others. Number 5. Okay, I'd like to do number 5, and then we're going to take a break, and I'll tell you when we take the break what the second half will look like here. Our classes always fly by. I always have like an idea that we'll have more time than we do, but I hope it's time well spent here for you guys. Let's see. All right, number 5 from the workbook. Here we go. Hayden bought 4 tickets to a football game. Okay. He paid 5% service charge for buying them from a broker. So this is where you buy it like on StubHub or whatever, where you can get, through a broker, Ticketmaster. There's a bunch of them. I'm probably forgetting the main one, but you guys know about that. Okay. His total cost was $105. What was the price of each ticket, not including the service charge? Okay. So now we've just read it. Now we're going to go back through it. And I want you, if you haven't done it yet, to write down what's important. So Hayden bought 4 tickets. Okay. He paid 5% service charge. Let's see. Total was 105. All right. And then basically I've done right now steps 1 and 2. And I also identified the known quantities. And now what is unknown? We just have to look. What was the price of each ticket? So the question is, and the unknown is the price of each ticket. That's what I'm looking for. We'll call that X. Okay. Nice. Jessica, you're like you're like feeding me the next step. That's a good job. All right. Here we go. So here's what we know. We want to find the price of the ticket after the service, or not including the service charge. So let's look at this here. We have the price of each ticket, right? And now there's a few ways to do this. I'm going to go with the way you have there, Jessica. That's good. So before the service charge, right? Before the service charge, if each ticket is X, 4 tickets is 4X, right? So 4 tickets is 4X. The service charge is 5%. Now, I want you to think of this. We're going to apply this. I'm going to give you a very straightforward one here. What is 5% of 100? Let's see. We're going to put 0.05. This is just a side example. We're going to do 5% of multiplication, 100. 5% of 100 is 5. Okay? So remember, when we're trying to find, the service charge, the tax, the whatever, we're always taking the, this is like the data point, right? The item. Well, I just started writing 2 different things. It worked out. So that's the data point, and we're just multiplying it by that amount of service charge, tax, discount, whatever. If it's a discount, we would subtract. Since it's a service charge, we're going to add it. Okay? So let's apply this same thing right here. 5% of 100, I wrote it as 0.05 times 100. How about 5% of the 4 tickets? How are we going to write that down? So we know that this is 5%. And what am I going to multiply that by in order to have, this is going to be the service charge. What do we think? Nice, nice. Okay, Cadence got it. We're going to multiply by 4x. I really want you to get used to it. We're going to be kind of separating these because this is just the item, right? The tickets. That's just the items. But the service charge, right? The service charge percentage is going to be multiplied by the cost, that cost of the items. Okay. And we look at that. What is all that equal to? 105. So now we go in and we can take this piece of paper and finish it up, clean it up. Okay. Now, when we get to, I think actually next week I might take a break from our lessons and go into factoring, because factoring is something that makes things much easier. Okay. So give me a thumbs up, sideways down if you know how I did this. Anybody know how I got that on the left side? Give me a thumbs up if you feel like you could probably do that on your own. No worries, no worries. Math, integrated math does not prepare you as well as I'd like for factoring. So I do a whole breakout lesson on that. Essentially what I did is I looked at the whole thing and I said, well, I can factor out a 4x from both terms and end up with, divide out of 4x, I get 1 here. Divide out the 4x, I get that 0.05. Now, that is just where we're going. I wanted to have that ready for you. But really what we can do is just go at it the same way here. Let's go ahead and do 4 times 0.05, 0.2. And then you can combine these two terms because it's just x to the first, x to the first. Remember, the rules of combining have to do when we add and subtract. Here, I could just multiply it. That's fine. I can multiply it all day long here. But here, we need to, yeah, good. All right. Here, we need to just combine and add together our two coefficients. Because the two coefficients, you just add those two together when you have the same type of term. We have a first power term here. So we're just going to get 4.2x is equal to 105. And then let's divide by 4.2. See ya. I know a lot of you probably have it working on it as we go here, so I'll just leave this answer out. I want you to see if you end up with the cost of each ticket and you feel pretty confident with it. So put your answer to the cost of the ticket in the chat. And don't forget the units, which are pretty easy in this. So don't just say like 45 what? 45 what? There we go. Jessica's second answer looks good. Good, Nelly. Got it. Perfect. Good, good. I like the specificity, how specific you are there, Haifeng. Good job. Let's see. Vivian, perfect. Curtis, perfect. Looking good here. Okay. So we are ending up with, anyone else want to throw it in chat? If you just got it, sometimes it's nice to get it in there before I push the pace here a little bit. All right, Cadence, very good. Perfect. Jackie, perfect. Lily, good job. I just need a little bit more of the units in there, Lily. So that's just a number. I need to know what it is and what it applies to, because it's $25 per ticket. There we go. Okay. Okay. I think that, excuse me, the sneeze. I won't. I think that that's about 4 problems we'll go over. I will be posting more videos on as I move through the classes. I'll be doing, recording the numbers we haven't gone over. So I'm going to go ahead and pause this video. So just hold up 1 second while I do that. Actually, I think I'm just going to stop it. All right.